Hi. In this video, we're going to have a look at the most recent exam paper for A-level Pure Maths 1, which is at the moment May-June 2022, paper 1-2. I have to say that at this moment, the mark scheme for this paper is not available. So that means I will just show you the way I would approach this paper if I had to take this exam myself. Most likely I will make some mistakes, and if I do, please let me know in a comment to this video, or if you know me personally, just send me the message. And with that being said, let's have a look at the very first question. So this is supposed to be a, and we're looking for the value of the positive constant a. The question is about the binomial expansion, and it's very helpful to state the formula for the binomial expansion, which is a plus b to the power of n equals to the sum, where k goes from 0 to n, of nck, a to the power of n minus k, b to the power of k. And if we apply this formula for the first bracket, that will be 3 plus x to the power of 5 equals to the sum, where k goes from 0 to 5, 5ck, now 3 to the power of 5 minus k, x to the power of k. And the second bracket will give us the sum, k goes from 0 to 6, 60k, 2x to the power of 6 minus k, a over x to the power of k. Now, let's look at what the question says. The coefficient of x to the power of 4 in expansion of 3 plus x to the power of 5. And then we know that in order to get the coefficient of x to the power of 4, we'll have to let k to be equal to 4. And it must be equal to the coefficient of x squared. So that's a bit more complicated. And we'll have to look at the power of x in the expansion. And the first bracket, 2x to the power of 6 minus k, will give us x to the power of 6 minus k. Now the second bracket, because we have x at the bottom, will give us minus k. And if we simplify that, that will be 6 minus 2k. Now, we know that we're looking for x to the power of 2. That means the power of x, which is 6 minus 2k, must be equal to 2. Now, solving this equation will give us minus 2k equals to minus 4. Therefore, k equals to 2. Now, in the first bracket, if we let k to be equal to 4, we will get 5c4 times 3, and then times x to the power of 4. And if we calculate that, that will give us 15 to the power of, and then x to the power of 4. Now, in the second bracket, if we let k to be equal to 2, that will be 6c2, 2x to the power of 4, then a over x to the power of 2. Now let's simplify that. It's going to be 15 times 16x to the power of 4, and then a squared over x squared, which gives us 240 x squared a squared. Okay, so now we'll have to equate the coefficient of x to the power 4 in the first bracket, which is 15, to the coefficient of x squared in the second bracket, which is 240 a squared. And now we can solve this equation to find a, which is a equals to the square root of 15 over 240. Which gives us 1 over 4. And this is going to be my final answer for the first question. 1 over 4. Okay, now let's move on to the second question. Now this is about the geometric progression. We know that the second term, I will call B2, equals to 10. And the third term equals to 8. So B3 equals to 8. And we're looking for the sum to the infinity. Okay, so first of all, I need to know the formula for the sum to the infinity of the geometric progression, which is the first term. In my case, this is B1 over 1 minus r, where r is the ratio of the progression. Now it looks like I will have to find the ratio of the progression, which in my case is going to be the third term over the second term, which is 8 over 10 or 4 over 5. Now, since I know the ratio of the progression, I can find the first term, which is the second term, over the ratio. So it's 10 over 4 over 5, which gives me 12.5. And now I'm ready to substitute all the numbers into the formula for the sum to the infinity. 12.5, which is the first term, over 1 minus the ratio, which is 4 over 5, or 0.8. And that is 62.5. I will state this as my answer for the second question. Now, time to move on to the third one. Okay, now we know the derivative of the function, and now we're supposed to find the actual function. So if you know the derivative, then the function is going to be the integral of the derivative. So we're supposed to integrate uh, 3 times 4x minus 7 to the power of 1 over 2 minus 4x to the power of minus a half dx. Now I will take 3 out of the integral. Now 4x minus 7, I will add 1 to the power, which is 3 over 2. And now I'm supposed to divide by the new power. And dividing by 3 over 2 will be the same as multiplying by 2/3. So I'll put 2 in front and divided by 3. And now don't forget to place the coefficient of x at the bottom. So we're done with the bracket. Now we do minus I will put 4 in front, add 1 to the power, which is 1 over 2, divided by the new power, and dividing by 1 over 2 would be the same as multiplying by 2 over 1. And don't forget plus c. Now let's simplify this a little bit. 3 and 3 will cancel out. 2 and 4, we can simplify it to make 2 at the bottom. And 2 times 4 is going to be 8. So therefore, our function will be 4x minus 7 to the power of 3 over 2 divided by 2 minus 8x to the power of 1 over 2 plus c. Now, in order to find c, we'll have to substitute the point, which is 5 and 5 over 2. So it means 5 over 2, which is the value of y, equals. If I substitute x to be equal to 4, in a bracket, there's going to be 9 to the power of 3 over 2 minus 16 plus c. Now let's calculate all of that, and we got 5 over 2 equals to 27 over 2 minus 16 plus c. And from here we can find c. And we're ready to state the final answer for this question. Y equals 4x minus 7 to the power of 3 over 2 over 2 minus 8x to the power of 1 over 2 plus c, which is 5. And I will leave this as my final answer. Next question, please. Okay, progression again. This time it's an arithmetic progression, and we know that the first term equals to k, the second term equals to 6k, and the third term equals to k plus 6. We're looking for the value of the constant k. Now, what do we know about the arithmetic sequence? We know that the difference between the consequent terms is going to be the same. So it means the difference would be equal to a2 minus a1. And the same result should be for a3 minus a2. So this part will give us an equation to find k. So I'll just do 6k minus k equals to k plus 6 minus 6k, which gives me 5k equals to minus 5k plus 6, and I will solve it for k. Zero 0.6. Okay, next question. Find the sum of the first 30 terms of the progression. I will need the formula for the sum of an arithmetic progression, which is the first term plus the last term over the number of terms, which is 30. No, sorry, over 2. And I multiply it by the number of terms, which is 30. Now, in this formula, I will need to know A30. I will use the formula for the nth term of an arithmetic progression, which is A1 plus D times n minus 1. Okay, so what's going to be our first term? Let's look at the previous question, and we know that the first term equals to k. And since we know that k is 0.6, I will say it's 0.6 plus the difference looks like we will have to find the difference. Now, if you look at the first term, it's k, and a2 is 6k, so the difference should be 5k. And since k equals to 0.6, we can easily find the difference, which is 0.6 times 5, so it's 3, times n minus 1, well, n is 30, minus 1, 29. Okay, calculating that gives me 87.6. Now we're ready to substitute this result into the formula for the sum of the progression. The first term, 0.6, plus the last term, 87.6, divided by 2, times 30. And that apparently equals to 788.4. I will leave this as my final answer, and I will move on to the next question. Okay, now we have the equation of the curve and the equation of the line, and we're given that the line intersects the curve at some points. Now, if the curve intersects the line, that means the y-coordinates are going to be equal. So I will make 4x squared minus kx plus k squared over 2 to be equal to x minus a. Okay, now I know that this should be true for x equals to 0. And I will substitute 0 into this equation. That gives me k over 2 equals to 0 minus a, which is minus a. I think I will just rearrange this equation and multiply by 2, so k squared equals to minus 2a. And I guess I will find a from here. So it's k squared over minus 2. Or, even better, minus k squared over 2. I will leave it for now, and I will proceed to the second point, where x equals to 3 over 4. Now, I'll have to substitute x equals to 3 over 4 to the initial equation, this one. Which gives me 4 times 3 over 4. I'll just substitute it without talking too much. Okay, so I got this. Let's square 3 over 4 and simplify this a little bit. So 9 over 4 minus 3k over 4 plus k squared over 2 equals to plus 3 over 4 minus a. Okay, so now we know that a equals to minus k squared over 2, and I can actually substitute it into this equation. Now minus and minus will give me plus, so it's plus k squared over 2. Okay, I got lucky here, and k squared over 2 on the left will cancel out with the k squared over 2 on the right side. And we have a common denominator of 4. So that means I can multiply both sides by 4 to get rid of the fractions, and I'll get 9 minus 3k equals to 3, so I can solve this for k. Minus 3k equals to minus 6, and finally k equals to 2. Okay, we're done for k. What about a? We know that a equals to minus k squared over 2. Let's substitute k equals to 2 into this. So I got minus 2 squared over 2, which gives us minus 2. Answer a equals to minus 2, and then k equals to 2. Let's move on to the next one. Okay, now we're given instead that a equals to minus 7 over 2. Find the values of k for which the line is tangent to the curve. Okay, so tangent to the curve means only one point of the intersection. That means the equation must have only one solution. Right, so that looks like a quadratic equation. So probably we'll have to use b squared minus 4ac equals to 0 to get only one solution. But before we do that, let us simplify the equation a little bit. Multiply both sides by 2 to get 8x squared minus 2kx plus k squared equals to 2x plus 7. And now let's collect all the terms on the left side. I will factorize the terms with x. Oh wait, that's supposed to be a plus, right? Yes. Sorry, getting a bit tired. Okay. So now we're going to use b squared minus 4ac equals to 0. In order to get just only one solution. So we got b squared, which is 2k plus 2 squared minus 4ac. 4 times 8 is 32 times k squared minus 7. That must be equal to 0. Let's expand this bracket, 4k squared plus 8k plus 4 minus 32k squared plus 32 times 7, 224 equals to 0. Simplify that and get minus 28k squared plus 8k plus 228 equals to 0. To make things easier, I'm going to divide by minus 4 and I will get 7k squared minus 2k, okay, minus 57 equals to 0, and that's the quadratic equation for k. I'm gonna solve it using the formula for the quadratic equation. Minus b, which is 2, plus minus b squared 4 minus 4ac plus 1596 over 2a, which is 14. So got 2 plus minus 40 over 14. Now, if I take it with the plus sign, I'll get 3, and with the minus, that's going to be minus 38 over 14, which is minus 2 and 5 over 7. So that these are my values for k. Is that what I'm looking for? Find the values of k, yes. Okay, I will just state it as my answer. Uh, 3 and minus 2 and 5 over 7. And I will move on to the next question. Okay, so the question is about the region bounded by the curve and the line. So obviously this question is going to be about integration, and I will have to find the limits of the integration, which is going to be the points of intersection of the curve and the line. So the intersection happens where the y coordinates are equal. Remember, power of 1 over 2 means square root, so 5 square root of x equals to 2x plus 2. I'm going to make a variable change straight away. And I will say that t equals to the square root of x. That means 5t equals to t squared plus 2. Okay, now let's make the quadratic equation out of this, and we get 2t squared minus 5t plus 2 equals to 0. I'm going to use the formula again. It's 5 plus or minus square root of 25 minus 4ac, which gives me 16 over 4 to a. 25 minus 16 is 9, square root of 3. Oh, sorry, 4. Okay, if I take with the plus sign, it's going to be 2, and the minus is a half. So these are going to be my limits of the integration. Now, for the integration, in order to find the area bounded by the curve, I will have to integrate the upper curve minus the lower one, which is 2x plus 2. Okay, so the integral from... Oh, hold on. I haven't found the x yet. Sorry about that. It's actually the value of t, right? And t equals to the square root of x, so the square root of x is going to be equal to 2, or the square root of x equals to 1 over 2. So that means x equals to 4, or x equals to 1 over 4. And now I can proceed to the integration from 1 over 4 to 4. Okay, let's integrate the upper curve, which is 5x to the power of 1 over 2, minus the lower curve, which is minus 2x, and then minus 2 dx, right? 5, then x to the power of, add 1 to the power, which is 3 over 2, divided by the new power, which means, okay, division by 3 over 2, it's the same as multiplying by 2/3. Minus 2x, add 1 to the power, and it makes it squared, divided by the new power, divided by 2, minus 2x. And the limits are from 1 over 4 to 4. Now, time to substitute the upper limit. It's going to be 80 over 3 minus 16 minus 8 minus, let's substitute the lower limit, don't forget the bracket, it's 5 over 12 minus 1 over 16, and then minus a half, which gives me 8 over 3 minus again 7 over 48. Okay, and then the minus and minus gives me plus, so altogether there's going to be 45 over 16. Not a very nicely looking answer, but okay, I'll just go for it. (45/16) it is. One more blank page. Okay, next one. Okay, so let's have a look at this question. Find the angle BOC, and we know the part of it, which is AOC, which is pi over 6. So we just have to find this small angle. We know that the length of the arc is BA, and we are working with the radians. So we'll have to use the formula for the length of the arc, which is R times the angle. Let's call it theta. Now we know that the length of the arc is 2. Radius is 10 times theta. So let's see, the angle is going to be 2 over 10. Simplify that, 1 over 5. Okay, so that's the small angle, but the one we're looking for is BOC. So that means I will just only have to add pi over 6 to that. So my answer is going to be 1 over 5 plus pi over 6. And I'm going to move on to the next one. Okay, hence find the area of the shaded region BPC, giving my answer to 3 significant figures. Okay, now let's have a look at the picture first. And we can see that the shaded area is going to be equal to the area of a sector BOC minus the triangle OBP. And this is going to be my strategy for this question. The area of a sector minus the triangle OBP. Okay, now let's start with the triangle first, and I'm going to recreate this picture. Here's my right angle triangle, and the hypotenuse is 10. We've got an angle theta. This is point P, that's point O. I'm going to use the formula for the area, which is a half AB sine C. Now, it is possible to use base times height over 2, so that means you would have to find OP first, and then you'll have to find the height. That's a bit more work to do, so I'm not going to do that. Now, I'm looking for the side OP, which is adjacent to the angle theta. Adjacent means cosine, so the OP is going to be equal to 10 times cosine theta, which is 10 times cosine 1 over 5 plus pi over 6. Now don't forget to switch your calculator into radians. And I got 4.49428 and so on. I'll just keep more digits for better precision. Now for the formula for the area, half AB times C, that's going to be a half times one side, which is 10, times the other side, 49428, times sine of the angle, which is pi over 6 plus 1 over 5. And this gave me 24.8093. Okay, now for the sector, sector, if we have to work with the radians, the formula is r squared over 2 times the angle. Now the radius squared is 100, divided by 2 is 50, times the angle in radians. Okay, now find the difference. So the sector minus the triangle will actually give us the answer. I got 11.37, correct to 3 significant figures, that's going to be 11.4. Okay, next question. Equation of the circle. And we have to find the values of A and B. And state the coordinates of the center. Okay, sure. So since the point 1, 1 is on a circle, that means we can substitute those coordinates into the equation. You get 1 plus 1 plus A plus B minus 12 equals to 0, and let's simplify that a little bit and get A plus B equals to 10. Let's substitute the other point, 2 minus 6, and get 4 plus 36 plus 2a minus 6b minus 12 equals to 0, or 2a minus 6b equals to minus 28. Now let's divide by 2 and get a minus 3b equals to minus 14. Now we get two equations for a and b, so we can solve them simultaneously. I'm going to subtract one from the other. B minus 3b, which is going to be plus, so 4b equals to 10 minus 14, which is 24. So that means b equals to 6. Now substitute this into the first equation, where a plus b equals to 10. Okay, so 6 plus what equals to 10? Correct me if I'm wrong, but it's 4. Okay, now let's substitute a and b into the equation of the circle and try to figure out the center of the circle. X squared plus y squared plus 4x plus 6y minus 12 equals to 0. That's the equation of the circle, and most likely we'll have to complete the square. So let's keep all x's and all y's next to each other. And at this point, let's complete the square. Looking at x squared plus 4x, it's going to be x plus half of the number next to x, which is 2. Oh, there's no need for x. Sorry. Minus that number squared, which is 4, plus y plus half of the number next to y, which is 3, squared minus half of that number, 9, minus 12 equals to 0. Okay, and x plus 2 squared plus y plus 3 squared. Let's move all the numbers to the right side and we get 25, which is actually r squared, the radius. So radius is 5, but we're looking for the coordinates of the center, which is going to be minus 2, minus 3. Okay, next question. Equation of the tangent to the circle at point A. Where is the point A? Point A is 1, 1. Okay. Now let's draw a quick sketch. So it's a circle, and the center is minus 2, minus 3. Somewhere here is point A, which is 1, 1. And the equation of the tangent looks like, the tangent line looks like that. Let's draw the radius as well, and as everybody knows, radius is perpendicular to the tangent. And because the lines are perpendicular, we can find the gradient, and the gradient of the line which contains the radius. And let's use the fact that tangent is going to be perpendicular to this radius. Okay, so the gradient is going to be difference in y, which is 1, minus 3 is plus 3 over difference in x, 1, minus 2, plus 2, 4 over 3. Now the perpendicular gradient will give us minus, and then the reciprocal of the gradient of the radius, which is minus 3 over 4. And then we know that the equation of the tangent should be in the form minus 3 over 4 x plus c. Now, how do we find c? We can substitute the point 1, 1. So 1 equals to minus 3 over 4 plus c. So from here, c equals to 1 plus 3 over 4, which is 1 and 3 quarters, which is 7 over 4. Okay, so now the equation of the tangent looks like y equals to minus 3 over 4x plus 7 over 4. Now that's not the form they're asking for, because it should be px plus qy equals to k. So I'm going to multiply this by 4 to get 4y equals to minus 3x plus 7. Okay, and I'll rearrange it into the form they're asking for. So it's 3x plus 4y equals to 7. And I will move on to the next question. Okay, differentiation. dy over dx. Okay, let's start. It's going to be 3. Derivative of any number, which is in this case 1, is 0. So proceed to the next term, minus 4. Now, derivative of the bracket, multiplied by the power, the bracket, subtract 1 to the power, so it's minus 1 over 2, and I multiply by derivative of the inside function, which is 3. Okay, so that gives me 3 minus 6 times 3x plus 1 to the power of minus 1 over 2. Okay, now let's find the second derivative. Derivative of 3 is 0. So next term, minus 6 times the power minus a half bracket 3x plus 1. Subtract 1 from the power, minus 3 over 2, times derivative of the inside function, which is 3. Simplify that, and we get 9 times 3x plus 1 to the power of minus 3 over 2. Let's take the answer, dy over dx. And the second derivative is, I'm just going to copy that. And I will move to the next question. Find the coordinates of the stationary point of the curve and determine its nature. Now, in order to determine the coordinate of the stationary point, I will have to equate the derivative to 0. I'm going to use the equation for the derivative from the previous question. Okay, and then minus the power of minus a half means I will have to divide 6 by the square root of 3x plus 1. Now let's assume that the square root of 3x plus 1 is not equal to 0 and multiply by it. And solve this for x. So divide everything by 3. Now move 2 to the other side. Square both sides. Subtract 1. It's going to be 3. So x equals to 1. That's going to be the x coordinate of the stationary point. Now, in order to find the y coordinate, I will have to substitute x equals to 1 into the equation of the original curve. So y1 equals to 3 plus 1 minus 4 times 4 to the power of a half. 3 plus 1 is 4, minus 4 times 4 to the power of 1 over 2 is 2, and it gave me minus 4. Okay, so now we know that coordinate of the stationary point is 1 minus 4. Okay, now in order to determine the nature of the stationary point, we will have to substitute this into the second derivative. Second derivative when x equals to 1. Again, we're going to use the equation for the second derivative from the previous question and hope that is correct. So it's going to be 9. If I substitute x equals to 1, I will get 4 minus 3 over 2. And that gives me 9 over 8. Now we know if the second derivative is bigger than 0, that means our stationary point is the minimum. And that's pretty much it. The stationary point is 1 minus 4, and in nature is minimum. Okay, we're ready to move to the next question. Okay, so functions and graphs. We have the diagram of the function y equals to f of x, and we have to state the domain of the inverse. Now we know that the domain of the inverse is going to be the same as the range of the original function. Now, just by looking at the graph, the range is on the y-axis. It looks like the range could be any number apart from this one. Right, so the function is never approaching 1. Well, it is approaching to 1, but it never equals to 1. So my range is going to be any number apart from x1. Okay, now we're looking for the expression for the inverse of the function, and we're going to use our fabulous two-step technique. So the first step is to swap x and y, or in this case f and x. So x equals to 2f plus 1 over 2f minus 1. And step 2 is going to be rearrange this equation to make f the subject. Okay, so I'm going to keep all terms with f on the left side and everything else on the right side. Then I will factorize. And then finally, I'll divide by the bracket. And say that the inverse equals to x plus 1 over 2x minus 2. That's going to be the answer. Okay, next question. Find g of f inverse of 3. So that means 3 goes into the inverse and the result goes into g. So the inverse of f when x equals to 3 is going to be 3 plus 1 over 6 minus 2, which is 4 over 4 or 1. And now this result goes into g. And g of 1, let's look at the formula for the g. X squared plus 4, so that means 1 squared 1 plus 4. 5. Okay, so the answer is 5. Next one. Explain why the inverse of g cannot be found. Let's have a look at the function g. So the function g is the quadratics, which looks like this. Now, obviously, this is not one-to-one function, which is necessary to in order to form the inverse. And that's the reason why. So I'll just say it's not a one-to-one function. And I will move to the next one. 6-mark question. Okay. Show that this can be expressed as 2x plus 1 over 2x minus 1. Okay, sure. We need the common denominator, so multiplied by 2x minus 1. And I got 2x plus 1 over 2x minus 1. Okay, so 2x plus 1 over 2x minus 1 is actually equal to 1 plus 2 over 2x minus 1. Okay, hence find the area of the triangle enclosed by the tangent to the curve at the point where x equals to 1. Okay, so that means I will have to find the equation of the tangent. Now, tangent is a straight line, so y equals mx plus c. Now, m is the gradient, and the gradient of a tangent is given by the derivative at a certain point, which is okay, x equals to 1. That's my point. Okay. So that means we will have to find the derivative. And we're going to differentiate this expression 1 plus 2 over 2x minus 1. Okay, so what derivative is going to be? Okay, derivative of 1 is 0, so it means 2 times the power minus 1. I got 2x minus 1. Subtract 1 to the power, I got minus 2. times the derivative of the inside function, which is 2. That gives me 4 minus 4 over 2x minus 1 to the power of 2. Okay, so derivative will give me the gradient of the tangent at any point x. Now, what's the point I'm interested in? It's x equals to 1. So that means I will have to substitute x equals to 1 into my derivative, and I will get minus 4 over 2 minus 1, which is 1. So all in all, I got minus 4. Now that means the tangent is going to have the equation minus 4x plus c. Now, in order to find c, I will have to substitute one point, which is on the curve. I know that x equals to 1, but I don't know what y equals to. However, I got the equation of the curve. It's 1 plus 2 over 2x minus 1. So I can substitute x equals to 1 into the equation of the curve. I think I will substitute it into the fraction even easier. 2x plus 1 over 2x minus 1. 2 plus 1 over 2 minus 1. That is 3. So I know the point. It's 1, 3. And that means I can find the equation of the tangent. So 3 equals to minus 4 plus c. So c equals to 7. Now let's sketch this triangle. So the line is minus 4x plus 7. That's point 0, 0. Now when x equals to 0, y equals to 7. So the point is 0, 7. Now what is this point? It's when y equals to 0. So x equals to 7 over 4. And now we can find the area of this triangle using the formula base times height over 2. So the base is going to be 7 over 4, and the height is 7. So it's 49 over 8. Okay, find the area of the triangle. Okay. I will state it as my answer. Okay, next question. Given that k equals to 3, find the exact solutions of the equation. Equals to 0. Okay, so first of all, I will make the variable change. T equals to cosine squared x. So I'll get a quadratic equation for t squared plus t minus 3 equals to 0. And I will use the formula minus b plus or minus square root of b squared, which is 1. 4ac is 48 over 2a, 8. That gives me t minus 1, or t is 3 over 4. Okay, substitute back. That means cosine squared x equals to minus 1, or cosine squared equals, x equals to 3 over 4. Now, taking the square root of minus 1 is, well, gives me no solutions. If I take the square root of 3 over 4, I should not forget about the two values of the square root. One is positive, or the other one is negative. Now, take the inverse cosine. Square root of 3 over 2 gives me pi over 6. And the second solution is going to be 2 pi minus the first one, which is 11 pi over 6. Moving on to the second equation, the first solution is going to be 5 pi over 6, and the second one 2 pi minus the first one, which is 7 pi over 6. All of them are going to my final answer: pi over 6, 11 pi over 6, 5 pi over 6, and 7 pi over 6. And the last one. Use the quadratic formula to show that when k is bigger than 5, the equation has no solutions. Okay. Now let's start with the actual equation for cosine to the power 4x plus cosine squared x minus k equals to 0. Now, if you remember, we made the substitution, t equals to cosine squared x. And we got 4t squared plus t minus k equals to 0. Now, we were looking for the value of t, which is minus 1 plus or minus the square root of 1 for EC is 16k over to a, which is 8. Now let's substitute it back into t equals to cosine squared of x. So we know that cosine squared of x equals to minus 1 plus or minus the square root of 1 plus 16k over 8. Now the big question is, when does this equation have solutions? We'll have to remember that cosine is actually limited. It's from minus 1 to 1. That means that the cosine squared should be in between 0 and 1. Okay, so let's combine this limitation and our expression for the cosine squared. We know that minus 1 plus or minus the square root should be less or equal than 1. And let us solve this equation. I'm sorry, it's inequality, not the equation. Okay, square both sides and we get 1 plus 16k less or equal than 81. So it means 16k is less or equal than 80. And finally, k is less or equal than 5. Now remember, this is when we do have solutions for this equation. Have solutions. So if k is less or equal than 5, then we do have solutions. Now, what would be the opposite? The opposite is when we don't have solutions. And if we have solutions for k less or equal than 5, then the opposite would be k is bigger than 5. So it means, therefore, when k is bigger than 5, there are no solutions. Which is exactly what I was supposed to show. Okay, and that seems to be the last question for this paper. I hope it was useful, and I hope I didn't make too many mistakes. But if you think that I did some mistakes, if I made some mistakes, again, please feel to let me know in the comments to this video, or contact me personally if you know me. Okay, and with that being said, bye.